Right, so I'm going to start with the homework from the 2nd of October, which was the pipes. I'm just going to do it in the main body here because... Here. I had a look at your attempts at this and they look pretty good, so that's good. Just make sure you make a conclusion, which some of you didn't. Okay, so trying to do the maths in the same way. How did I draw it? Okay. So, green arrows. Okay. So we're trying to get the length of this. This bit here is lambda over 4. It's node to antinode. And then this bit here is lambda over 4. So the length is lambda over 4 plus lambda over 4. And then, like I said, you can just use your calculator to get a quarter plus a quarter. So a quarter plus a quarter is a half. Don't forget to put the lambda back in. So it's lambda over 2. And then did I isolate it there? I did, yeah. So then we isolate lambda. So here I'm going to multiply by 2 and multiply by 2 to isolate lambda. So I get lambda equals 2L. Okay, and then we go C equals F lambda. C equals F times 2L, and then we isolate F. So we divide by 2L, divide by 2L. Did I change it into a fraction? I did, yeah. Okay. So that's C over 2L equals F, and I can write that as a half C over L. Yeah, there's an invisible 1 here. And that's my first harmonic, or my fundamental frequency. Okay, so we go again then for this one. Trying to get the length. This is node to antinode, so it's lambda over 4. This is node to node, so it's lambda over 2. And then this one is node to antinode, so it's lambda over 4. So we're doing lambda over 4 plus lambda over 2 plus lambda over 4. So in my calculator then I can just do a quarter plus a half plus a quarter, which gives me 1. So L is 1 lambda, or lambda is L. So C equals F lambda, C equals F, and we put the L in here. Again, we want to isolate our F, pink. So we divide by L to cancel and divide by L to balance. So that is just C over L equals F. This is the second harmonic. So hopefully from that you can see that F2 is twice F1. This is essentially 1 times C over L. And this is a half C over L. So F2 is double F1. Okay, and then the last one we're going to do, which is enough to see the pattern. So that is the third harmonic. We want to know the length. So this length here, lambda over 4, this one is lambda over 2, this one is lambda over 2, and this one is lambda over 4. So lambda over 4 plus lambda over 2 plus lambda over 2 plus lambda over 4. So a half plus a half plus a quarter plus a quarter. So that is 3 over 2. Put the lambda back in, so it's 3 lambda over 2. Yellow. Right, we're going to try and isolate this. So we'll multiply by 2 to cancel the divide by 2 and multiply by 2 on the far side to balance. So 2L equals 3 lambda. And still want to isolate lambda, so we'll divide by 3, green. So lambda is 2L over 3. Okay, then we go over here and we do C equals F lambda. So C equals F times 2L over 3. I'm trying to isolate F. So I'll multiply by 3 to get rid of the divide by 3 and multiply by 3 to balance. So 3C equals F times 2L. Still trying to isolate F. So I will divide by 2L to cancel and divide by 2L over here. So that is 3 over 2 times C over L equals F, and this is my third harmonic. Okay, and essentially what we have is this first one's a half, this is 1, and this is 1.5. So that means that the third harmonic is 3 times the first harmonic. Okay, so the first harmonic was a half C over L. The second harmonic was twice this. So it was 1 C over L. And the third harmonic was 3 times the first. So it was 3 times a half C over L. Does that make sense? Which becomes 3 over 2. Okay, so our conclusion is that all harmonics are present in a pipe open at both ends. And that's our conclusion. Okay, so like I said, most of you did very well with that. You have to be able to go through those maths for both of those. And literally do that question, like prove that only odd harmonics are present in a pipe closed at one end. Prove that all harmonics are present in a pipe open at both ends. Okay, so the pipe open at both ends behaves like the string. You've got if you double it, you'll get a harmonic. If you double it again, you'll get every single one is present. Whereas up here, we were saying that we only get the odd ones. Okay, so that is that homework from the second.